Hello, my student. Today we continue study differential equation class, and today we covered section 1.6. Here is at least three different type of equation. First, we solving equation by substitution. Then we talk about exact equation, and last one will be equation second order, whereas one of variable is missing. Okay, we start. First is equation by substitution. Because it's by substitution, we don't have any theory here. I show you some examples, and this example help you how you can solving this equation. For example, you have dy dx equal x plus y plus 3 square. I think it's easy to see. We need substitution. Some new function, who is x plus y plus 3. If you take a derivative, dv dx will be 1 plus dy dx. Use this substitution, plugging in our equation. We have dv dx minus 1 equal v square. dv dx equal v square plus 1. This is equation with separable variable. This means we have dv over v square plus 1 equal dx. Took integral for both sides our equation. We have arctan inverse function for tangent equal x plus some parameter c. If we take in tangent for both sides, you have v equal tangent x plus c. Or we go back with our old variable. We have x plus y plus 3 equal tangent x plus c. And this means y equal tangent x plus c minus x minus 3. This is our final answer. You see, use substitution. We're solving this equation like very simple equation. One more example. Example 2. Let's go. We have 2xy dy dx equal 4x squared plus 3y squared. I think first we divide both sides for 2xy and see what happened. We have our derivative dy dx equal 4x squared plus 3y squared over 2xy. And if you separate here, you have dy dx equal 2x over y plus 3 halves y over x. I think we're ready for substitution too. Here this fraction, I think it's y over x. If you substitute with some variable v, plug in new function, it's mean y over x, it will be v. This means y equal x times v, and dy dx will be v plus x dv dx. And our equation for this situation, we can rewrite v plus x dv dx equal 2 over v plus 3/2 v. Move v in the right side and simplify. We have x dv dx equal 2 over v plus v over 2. Okay, this means x dv dx will be 4 plus v squared over 2v. We have equation with separable variable here, and this means we have 2v over 4 plus v squared dv equal dx over x. Take it integral for both sides. We have, we're doing couple of time. Integral is like left part. Okay, maybe I'm doing one more time step by step. And here is 4 plus v squared, it will be c. Then 2v dv, it will be dt. And this means I have integral dt over c, dx over x. Here I have ln c equal ln x. And you remember, for if you have all is ln, it's better if you write your constant parameter like ln c, because ln c can be any number, positive, negative, and nothing changing. Okay, here I have ln 4 plus v squared equal ln x times c. It's mean 4 plus v squared equal x c. Here we remember what is v is. This means y squared over x squared equal x c minus 4. And multiplied by x squared, we have y squared equal x cubed c minus 4x squared. What I not write root here, because y in this answer can be positive or negative. If I write root, it means y only positive. I think it's better if we save this kind of answer. Okay. Now I show you, I think it's 2 examples from your homework for questions similar into your homework. It's help you doing homework. Okay, number 16 from your book. It will be first derivative equals square root x squared plus x plus y plus 1. You can easily see what kind of substitution is. It's x plus y plus 1 equal v, and equal v. Then dv dx will be 1 plus dy, dy dx. Okay, plug in there. You have dv dx minus 1 equals square root of v. This means dv dx, right? I told, sorry, this is I say what I do it. I say dv dx and write dy dx, dv dx. Okay. Now what we have, it's mean dv dx equal square root of v plus 1. Separable variable, square root of v plus 1 equal dx. Take it integral both side. And here, I think it's easy substitution, v like c squared. This is substitution not about how solving differential equation is about how counting your integral, and this dv will be 2c dt, and you have over c plus 1. Here it gives us integral 2 minus 2 over c plus 1 dt. Here will be 2t minus twice natural log c plus 1, and all of this is equal x plus c. Go back and remember what is t was and what is okay, it will be 2 square root of v minus 2 ln square root of v plus 1 x plus c, and then remember what is v is, and final answer is will be twice square root x plus y plus 1 minus twice natural log square root x plus y plus 1 plus 1 equal x plus c. Okay, this is final answer. We not spend time for simplifying. One more question, question number 28. Here we have x e exponent y y prime equal twice e exponent y plus, I think it's x cube e exponent 2x. I think a substitution here is will be e exponent y, it will be v, then dv dx will be e exponent y dy dx. Okay, this is help us right part our equation. It will be x dv dx, sorry, it's left part, and right part is will be twice v plus x cube e exponent 2x. Okay, move all its one side and divide by x. Same time I have v prime minus 2 over x v equal x square e exponent 2x. Okay, what we have now? We have linear equation. This means we can find multiplicator. It will be e exponent minus 2 over x dx. This will be e exponent minus 2 ln x. It will be 1 over x squared. Okay, multiplied our equation, this equation I put in the star. For 1 over x squared we have 1 over x squared v prime minus 2 over x cube v equal e to the power 2x. Left part our equation is whole derivative from product 1 over x squared times v, and we take it integral for right, e to the 2x dx. This is give us 1 over x squared v. This will be 1/2 e to the 2x plus c. This means v equal half x squared e to the 2x plus c x squared. Remember what is v is? This means e to the power y equal 1 half x squared e to the 2x plus c x squared. You can stop now, or you can rewrite y is natural log 1 half x squared e to the 2x plus c x squared. Okay, that's it. Now we study one more type of equation. It's called exact equation. Okay. Exact. Exact equations. If you can rewrite your differential equation this shape, first m function depend x on y dx plus n function depend x and y dy and all it's equals 0. If and only if first I give you definition, then we write theorem. And if differential m part of differential respect y equal part of differential function n respect x, this equation called exact. And here we have some theorem. If you have exact equation, if and only if exists function f depend xy who is equal integral mxy respect x and plus some function g depend only y. Then partial derivative f, partial derivative respect x, it will be function m, and partial derivative f respect y, it will be your function n. But if we take it derivative for what we defined, this means derivative for dy from integral m xy dx plus gy. Okay. Try solving some example and it will be much easier understood what we have here. Let's go, we have this kind of function 6xy minus y cube dx plus 4y plus 3x square minus 3x y square dy equal 0. Okay, this one is our function m. This one is our function m. First we need checking this is exact equation or not. This means take a derivative function m respect variable y. It's give us 6x minus 3y squared. Take a derivative function n for variable x. This is give us 6x minus 3y squared. How you can easily see this is equal. Because it's equal, this means we can use how we're solving exact equation. fxy will be int m function 6xy 6xy minus y cube, and we take it for dx, and plus some part of function depend only y. Okay, what we have here, take a in antiderivative respect to x, we have 3x square y minus y cube x, and plus some function gy. Now we need found derivative this function for respect y. What is will be df dy, it will be 3x square minus 3y square x plus g prime from y, and it's need to be equal our function m. How you remember our function m is, I write different color when we not mixed up, it will be 4y plus 3x square minus 3x y square. If you're looking for this equation, what we have now? 3x square left part, 3x square right part, minus 3y square x minus 3xy square. This means we have equation g prime from y equal 4y. We use integral, we have gy equal 2y square. Finally, right now we're ready for right answer. Okay, our answer will be our function f, big F, this means 3x square y minus xy cube plus 2y square, and because whole derivative this function is equals 0, this means function equal constant equals c. This is answer for our exact equation. Okay, solving one more example. This example from your book, something similar from your homework. It's question number 38. Here we have x plus tangent minus 1 y dx plus x plus y over 1 plus y square dy equals 0. This means m function is x. I don't like this writing. I write like we can see this is arctan y, because here we have inverse function for tangent, and n will be x plus y over 1 plus y square. Okay, dm dy, you see I say dy and write dy we call only derivative for arctangent. This will be 1 over 1 plus y square, and dn dx, it will be 1 over 1 plus y square is equal. This means we have exact equation and we can solve. Okay? What is our f? Will be equal integral from x plus arc 10 y dx and plus some function depend only y. Okay? Antiderivative from x will be x squared over 2. Antiderivative from arctangent y, because it's not depend x, it will be only work like constant. This means x multiplied by arctan y plus g from y. Take it derivative for here. We have df dy. It will be nothing from x squared over 2. And here we have x times 1 over 1 plus y squared. Okay? Plus g prime from y need be equal our function n. This means x plus y over 1 plus y squared. Okay. X over 1 plus y squared plus g prime from y. Here I separate for two fractions. Here it will be one fraction x over 1 plus y squared, and second fraction y over 1 plus y squared. Okay, this part is equal. This means I can cancel it, and we have g prime from y equal y over 1 plus y squared. This means g from y integral y over 1 plus y squared dy. We did a couple of times this integral. It will be 1/2 natural log 1 plus y squared. Because it's always positive, I don't need absolute value. Okay, I think we're ready for write our answer. It will be x arctan y plus 1/2 x squared plus 1/2 natural log 1 plus y squared and equals some constant c, where c any number. Okay. And today we study one more type of equation. Here is equation where one of your variable is missing, and this is reducible second order equation. Now let's go first situation. Dependent variable y is missing. This means y missing. Because you have second order equation, this means you have some equation depend x, y prime, and y second prime equal 0. Here we have substitution. I think it's first derivative. We substitute some new function depend x. Okay. What will be for second derivative? Second derivative is first derivative taken derivative. This means p prime. Okay, and our equation now will be equation whereas you have x independent variable, function, and first derivative this function. This means if before we have second order differential equation, now you have first order differential equation. This means after solving and found p, you remember p is first derivative for y, and y will be integral from y prime dx, or our situation is p dx. Doing some example. Let's go. We have x second derivative y plus 2y prime equal 6x. Here we don't have y. This means we can rewrite our equation like x p prime plus 2p equal 6x. This is linear equation. Now divide by x, and I write linear equation as standard form, equal 6. Here is our multiplicator will be e exponent 2 over x dx. It will be e to natural x twice. It will be x squared. Multiplied by x squared, we have x squared dp dx plus 2x p equals 6x squared. Left part is whole differential for x squared p, and right part we take it integral. We have 6x squared dx. It will be 2x cubed plus c. Okay, this means our p will be, we divide by x squared, it will be 2x plus c over x squared. This means we have equation y prime equal 2x plus c over x squared. Because we integrate and have second parameter, I write c1 here. Okay, this means my y will be integral for this function. This will be x squared. Oh, practically I need to write minus c1 over x. But it's minus or plus, it's no big deal, because it will be any constant, okay, and plus c2. But here is important. This is our final answer. Okay, what happened if your x missing in your equation? Okay, B situation. Independent variable is missing. Okay, let's go. We have equation whereas you don't have independent variable. This means equation depend y prime, and second derivative. Okay, here we pretend our function p, it will be function, it's exactly first derivative. But what happened if you try found second derivative? It will be first derivative found derivative, but it means you have found dp for dy times dy for dx, because here we pretend y is independent variable. Okay, and what is happened? It means you have here is like p prime times p. Okay, let's go, and this is it. You have equation whereas you from y stay y, from y prime you plug in p, and from y second derivative you plug product p prime p. Okay, after you found p, you can found and y2. Okay, doing some example. For example, I have y second derivative equal y prime square. This is our example. Okay. This means here I have y, second derivative as will be p prime p equal y prime is p square. A little bit simplified, you have y dp dy. You remember y work here as like independent variable equal p, because p square and p I'm cancelled. Okay. This is equation with separable variable. This means here I have dp over p equal dy over y. Take it integral both sides, and it gives us natural logarithm p equal natural logarithm y. I need to write plus c, but I write plus natural logarithm c, because natural logarithm c can be any number, positive or negative. It's exactly what I need. What this is, use trigonometric identity, give me cy. Okay, and here I have one more time c1. Here I have dy dx equal c1y. This means I have dy over y equal c1 dx. Natural logarithm y equal c1x plus c2. This means y equal e to the power c1x plus c2, or y equal a e to the c1x. Because here I separate, and a, whereas a is e to the c2. You can use this fact. Okay, this is my final answer. Try solving two more examples. It's from your homework, for similar your homework. Number 46. Here we have x, y second derivative plus y first derivative equal 4x. How you can see, this is differential equation without y. This means y prime equal p, and y second derivative will be p prime. Okay, we have x p prime plus p equal 4x 1 over x p equal 4. Linear equation, rho will be e exponent dx over x, e exponent ln x. This means x. This means we have exactly xp prime plus p equal 4x. Give me xp equal integral 4x dx 2x squared plus c. This means p equal 2x plus c over x. Oops. Dy dx, it will be plus c over x. And it means our function y, it will be 2x plus c1 over x dx, y equal x squared plus c1 ln x and plus c2. This is final answer. Okay, general solution our equation. And last question, what I want to show you today is 52. Here you have y cube, y second derivative equal 1. Here is equation without independent variable x missing here. This means first derivative will be p, second derivative will be p prime. Plug in here and see what happened. Y cube p prime equal 1. Okay, this means here we have y cube p dp and dy equal 1 with separable variable. This means p dp equal dy over y cube. Take it integral both sides, and we have p square over 2 equal negative 3. This means negative 2 y negative 2 power divided by negative 2 plus c1. Okay, p square equal c1 minus 1 over y square. Okay, this means p, it will be c1y square minus 1 square root divided by y. Remember what is p is dy over dx. Oh, sorry, what is index here? It's y square. Okay, c1y square minus 1 over y. This means here we have dy, y there, and divided by this square minus 1 equal dx. Take it integral both sides. Okay, we have 1 over 2c1 square root c1 y square minus 1 over 1 half equal x plus c2. Okay, this means I have square root c1 y square minus 1. It will be c1x plus c1 times c2, but I can write only c2 because it's not dependent, it's some different parameter. Square it and simplify it. I think I'm not simplified, I'm only squared. It will be c1x plus c2 square. This is general solution our equation. I think it's it what I want to tell you about section 1.6. Don't forget doing your homework. Okay,